Hello, and welcome to my office. I'm Dr. T. Today I'd like to talk a little bit about units. Units are what provide context to our values. So values are what you'd think of as a number. But a number by itself, just the value, doesn't have any context. And if I were to tell you, say, 42, that wouldn't mean anything. However, if we have an agreed upon context, then that will mean something. So if I say 42 cows, you now have an idea of what 42 cows are. We have some context. Units are going to be that context, and they need to be accompanying any of our values to get, an actual number, something that is understandable by the speaker, maybe me, and the listener, say you. Now, units, once again, can be anything. They just have to be something that we are both familiar with. And in antiquity, units were quite often things that were readily available. So the classic would be the Caleb seed, and I'm probably butchering the pronunciation of that. This was in the Mediterranean area, North Africa, Middle East, Southern Europe, a fairly common foodstuff. And they were believed at the time, although mistakenly, that they were of particular uniformity. They're not. They vary just like any other seed does. But the idea behind these was, hey, we all eat these things, or are all familiar with them. We all know how much they weigh. It's not much. And thus, we could communicate the weights of things in Caleb seeds. And we actually still do to this day. And you're thinking, wait, what? We do. Particularly useful for things like precious rocks, diamonds, emeralds, etc. The Caleb seed became the modern-day carat. Additionally, we can use it for purity of gold and other precious, gold. Due to a rather interesting quirk of history, Roman coins of a particular common variety were traditionally 24 calebs in weight, and, if 18 of those calebs are gold, then you know it is 3/4 gold. So 18 karat gold. Of course, Caleb seeds weren't the only ones used. Barleycorns were a popular one, especially for length. And depending on where you're at, it would be what units you would use. This, of course, leads to things like the wonderfully convoluted and confusing English system that does still get used. And, of course, scenarios where a gallon of wine and a gallon of water are two different volumes. With these confusions in mind, in the late 18th century, and actually on quite a few occasions before and since, world leaders have gotten together to say, hey, let's make a simple unified system. And the one I'm going to focus on is the metric system and its descendants. So late 18th century in France, we get the metric system, and this comes up with a couple of revolutionary ideas. For starters, we're not going to have two units with the same name doing slightly different things. So no gallon of wine versus gallon of milk or whatever. But we're actually going to make things even simpler. We're only going to define a couple of core units, a couple of what we call base units. Things like length and weight, etc. And at this time, there's only 7 of these. These units are then going to be used to derive other units. So for instance, the meter, which originally was defined based on the length of a meridian around the Earth, has since been defined as a distance light travels in a very specific, very short period of time. But if you have a meter, you can then define your units of volume. Because you have a unit of length, you can say, okay, this unit of volume is going to be the volume of, say, a cubic meter. Or, in the case of the one we most often use, the liter, it's the volume of 1/10 of a meter cubed. So a cube, 1/10 of a meter by 1/10 of a meter by 1/10 of a meter. Originally, mass was going to be under the same scenario, saying that, hey, a gram was going to be, or I should say, it's always been defined by the kilogram. A kilogram was going to be the mass of water in 1 liter. It turns out that was really an absolute pain, and that one's actually still in flux and won't be settled down to a physical constant until May 20th, 2019, which, as I'm speaking, is in the future, although presumably you may or may not be in the future. You know how that goes. Okay, now, of course, units do need to vary in size. If I want to start communicating, say, the length of bacteria in meters, That's going to be awkward. I mean, I can do it. I can put a whole bunch of decimal points or use scientific notation, but that's just awkward. So the metric system then included this next feature, and that was prefixes. So you had a meter, but we were going to change the size. Now, in other units, you just use, or other systems, you just use other units. You had a pint and a gallon and an ounce, and once again, this was getting really confusing and really hard to convert between the two. Not horrible for some cases, but in others, absolute nightmare. Well, the metric system uses prefixes, and those prefixes are going to correspond really with where you put your decimal point in. So deci would be 1/10, centa 1/100th, milli 1/1000th. So if I have a millimeter, that's 1/1000th of a meter. I'm building my scientific notation into my unit. If I want to switch between the two, I move my decimal point according to where things are at, and things work well. As I've mentioned, a few changes have taken place since the late 18th century. Currently, we are using the system known as System International, or SI system, which is somewhat redundant if you think about how that abbreviation works. That was developed in 1964 and has had some major revisions, the most recent one being November 2018, which is making the change to units such as the kilogram and the mole coming up in May 2019. With that, there has been a couple of interesting artifacts. Back in a previous system from the 1950s, there was a unit of volume called the cubic centimeter. This is exactly the same as a milliliter. It's the same unit of volume. If you look at the way the definitions are, a milliliter would be a cubic centimeter, and it's quite often abbreviated CC. This one is out of favor. It is still used a little bit in medicine, although there's strong emphasis to get rid of it because it's too easily confused with double zero, so accidentally giving a patient 100 times the dose than what they should be is, shall I say, a bad thing. It's also still used in automotive, etc., because once you get used to using something, it's hard to change, even if it's been quite a while since the change has taken place. Another point I would like to bring up is with the prefixes is an interesting quirk on the prefix for micro. Micro is 1/1,000,000th. So it would be, of course, used for small things. So micrometers would be something you might use for like cells, or microliters might be something you'd use to measure the volume of drops of water. A drop of water is typically around 20 microliters. The SI system official treaties define the symbol for micro as the Greek letter mu. It looks kind of like a U, but with the tail in the front and going down. Unfortunately, there has been a couple of issues. When handwriting the mu, some people are kind of sloppy, and it can turn into an M. Well, M would be for milli, and that would be off by a factor of 1,000. Now, for most applications, you don't write, you type. If you're working in Word, you would do, say, insert symbol and put in the mu. But for some reason, we still use handwriting for medicine, so doctors' orders and scripts are written out by hand, for some reason, still, in 2019. And it turns out that there's been more than a few oopses that went. So in the United States, medical folks generally don't use the mu. They use an MC, which is unlike any unit that they would expect to have. So it doesn't turn into something else. It would turn into nonsense if your handwriting was bad. And in the UK, the common, like microgram, which would be a fairly common unit that might actually be written, is written out in full. No symbol or abbreviation on that one. Otherwise, yeah, those are some units. Always interested in converting in between them, and a little bit of background on those. So for that, I will see you next time.